Hello, good day, and welcome back to the Baking Consult. Today, we'll get to see how you can design a suitable pad foundation for any structure. And keep in mind that before you design for your pad foundation or any foundation at all on Prota-Structure, you must have completed your analysis and possibly completed your design for your beams, your columns, and your slab, because all those load are what will be transferred to the foundation. So without wasting much time, the first thing to do before you design your pad foundation is you have to set the concrete grade and the reinforcement grade, and also select the size of the reinforcement you intend to use for your pad foundation. So we'll come to analysis and we'll come to building analysis. Then if you look at this part, you will see foundation over here. So the concrete grade is 25/30, while our reinforcement grade is 410. We can as well change that. So to make modification to that, we can click on this edit materials over here. Then we'll move from this default materials and come to foundation floor. So on our foundation floor, we have concrete grade of 25/30 and a grade of steel of 410, our FY and our FCU. But in this case, we are more concerned about, we are going to stick with these two, but we'll be changing the rebar diameter. So I will unselect all and I would select, I want to use just Y12 and Y16 for the design of my pad base. So I will come here and click Y12, and I will come to this place and also select Y16. Okay, so that is all. This is all set, and we'll close this part and we'll start to design for our pad base. And to design for the pad, click on story 0, and this is our story 0. So to insert my pad base, what I will do is I will select on any column of my choice, any one I want to start with, and I will right click. If I right click, you will see there's an option for insert pad base here. So I will click. When you open this up, it will ask you for some vital informations, just like our footing depth, also our allowable stress of soil, which translates to our soil bearing capacity. So to better understand this, let me just show you what it's requesting for. So if you take a look at this picture, you will see a simple pad base that has been brought up here. So this is our column and this is our pad base. So when we are talking about the footing depth, of course, you should know that this is our depth, and we cannot just decide the depth that we want to use. To decide this depth we want to use, we have to make proper reference to our code of practice. So for this class, I will be making reference to Eurocode. And if you open with me BS 8004 2015, which is our code for practice for our code of practice for foundations, and take a stroll with me to page 36, I believe 35, 36. Let's scroll down to, okay, this is page 36, and we'll look at our pad foundations. So we are talking about the thickness, which is our depth. So if you look at this clause 5.1.2.2, it said that our thickness, the thickness of a pad foundation should not be less than 150 mm. So we should put in mind that we are not selecting any thickness that should be less than 150 mm. And also, before you even decide to say you want to use a pad foundation to support any structure, there are some key criteria that you should consider. And if you come down to, remember that our pad foundation is a type of spread foundation. So our spread foundation, we have pad, strip, raft, and the rest. So if you look at the choice for design of a spread foundation, there are some things you should always consider before you decide that this structure, a pad foundation, will support it. And one of this is the magnitude of the deposition of structural load. So that means the kind of load that is coming on that structure. Is it a warehouse? Is it a residential structure? Is it a school? So you should consider that. Then also the bearing resistance of that ground. Like we said, that's the soil bearing capacity of that soil. the characteristic of the ground. So you can go ahead in your time and go through this criteria that will help you to decide if you are designing a structure for a pad foundation. Then talking about this bearing resistance of the soil, which is the soil bearing capacity, I would also like you to just few seconds open with me to page 5 of this same code. So if we come to 5 or 6 bit, let's go to page 5, I believe. Okay. So if you come to page 5, you will see the classification of our soil bearing capacity. So less than 10 kPa is extremely low, and very low is between 10 to 20 kPa. Then coming to high, we have between 75 to 150 kPa as our high soil bearing capacity. So you should have a common understanding of this bearing capacity before you even decide that you should design any structure for a pad base. Furthermore, if you come down to this other clause 4.1.2, you will also see that you look you check out for where you can find the adequate bearing capacity is always typically below 2 meters. So that means if you are getting a high bearing capacity, let's say between 75 at and 150, and you are getting it at the depth of about 4 meters, then it means that site is not suitable for a pad foundation. Remember, as a structural engineer, you are dealing with lives, you're dealing with properties, investments. So at every point in time, you should be making proper reference to your code of practice. So and also, if you also look at this part, it says that our dense or coarse soil should be above a water table. So in cases where when they were carrying out the soil investigation, they encountered water on the site, you should know that that site is not suitable for a pad foundation. Then another addition is that your spread footing uh, should not be placed on a non-engineered feed. So in this case, it's talking about your blinding. So you should not place your pad base directly on the soil. There should be an engineered feed. That means you have to provide blinding so that the pad base does not have direct impact, does not have direct contact with that very soil. So you can take your time and go through all these clauses for you to decide if you are actually designing that site for a pad foundation or another type of foundation. And if you go back to here, you will see that this is the blinding we are talking about. It has to uh you have to provide a blinding for our pad base. So I brought out some of those conditions for your choice of designing with a pad foundation. So we have the bearing capacity, which we just discussed, then the type of the structure, considering the load that is coming on it as well, whether it's a low rise, high rise, then also the water table, where you were able to encounter water table. Were you able to where did you get did you encounter water table on the site during investigation? Then also, it is not just okay to have a good soil bearing capacity, but at what depth did you encounter that bearing capacity? So for this very structure that we are talking about right now, we have a soil bearing capacity of 125 kPa, which is between to 75 to 150, which is between high. Then the type of structure is a low rise. Of course, it's a simple residential structure. Then during the soil test investigation, there was no water was encountered on the site, and the depth of our bearing capacity, our 125 kPa, was gotten at 1.1 meter, 1100 millimeter, which is 1.1 meter. So this is not up to the 2 meters, which is proposed by our code. And remember, why we are doing our pre-analysis for this very structure, we said our depth of foundation is 1.2 meter. So if we are having a bearing capacity of 125 kPa at 1.1 meter, so it means we are very, very safe going as deep as 1.2 meter. So with this understanding, let's go back to our software and insert this different data for our design of pad foundation. Now, if this video has been helpful to you till this point, kindly like it and do well to subscribe to our channel. Also turn on the notification, click on the notification bell so that you can get notified anytime we post new set of videos. So the first thing we'll make modification to is our foundation depth. What is the thickness of the pad base we intend to use? So we can start from a smaller size, knowing fully well that if that does not pass, we can as well increase the thickness of our pad base. But for the purpose of this class, and not to make this video too long, I will go with 350 mm as my thickness. I'll leave the taper height as 0, so surcharge height I'll leave it at 700. Eccentricity, no, I do not want that. Then allowable soil bearing capacity. Allowable soil bearing capacity, you remember it was 125, so I will come here and type 125 from our soil bearing capacity. And our concrete cover, I will leave this at 40 mm. You can go back and see our previous videos which we discuss the concrete cover extensively and the choices governing the selection of your adequate concrete cover. And we stick with 40 millimeter. So our steel bars on our x direction, let's start with 16, then y direction. Let's start with 12, then y direction 12 as well. So the next thing to do after I've inputted these parameters is to click on calculate, and it has made our calculations for us. So these are our column properties, this is our axial load, and it has provided a footing dimension of 1 meter by 1 meter. So what you have to do in this very section is you do your checks, our punching checks at the column face. So you check, take a look at your checks for the punching. So it is okay at 1.5D is direction 1 and direction 2, they are okay. Then also we look at the share. Our share is okay in both XX and YY direction. So you always have to check this if they are okay or they are not okay. So after looking at your after taking a look at your checks, we have to look at the reinforcement here and the spacing it is providing for us. So it is providing Y12 at 150 mm both on the X and on the Y direction. So we can make modification to this, and let's see. If we choose to use Y16, it will automatically update and it will put our Y16 at 250 mm. So now this all depends on your own choice as a structural engineer. So we can also come down here and look at this. If we change this to Y16, also at 250 mm. So you look at the area of steel required, which is 700, then the area of steel provided by area of T provided by providing Y16 at 250, we have 804. Let's take this back to Y12. You see, we have 753. I feel more comfortable with Y16 at 250 because it provides a higher area of steel because it provides a higher area of steel. So I'm just going to click OK and click OK. So yeah, we are done with the pad base of this very column, and let's have a look at what we have done so far. So if you see, if you rotate, this is our pad base. So it is as simple as that. This is going to be a very short class, so do not forget, if this video has been helpful to you to this point, please like it, subscribe to our channel because we have a lot of things coming your way. Do not forget to turn on the notification bell as you will get notified when we upload new set of videos. So we are done with the first column or the first pad base as well. Then now let's come to designing of this other one. We'll right click, we also insert our pad base. We are going to stay with the same parameters that was provided, that was selected for the previous pad base. It will automatically update this here. So I will click on calculate, and you see it has provided a different section for me. So the previous one was 1 meter by 1 meter, but in this case we have 1.2 by 1.2. So I can choose to increase any of these either on the X or on the Y direction. Maybe I want to make it a different size. Let's just increase this. If we increase this, you'll see that the other part is reducing. So now we have 1.3 on the LX direction and we have 1 meter on the LY direction. So this is our 1.3 and this is our 1 2. We can choose to increase this as well, and this will keep reducing. But let's stick with a square footing. So our square footing, if you click here, it will automatically make it a square footing. So we are sticking with the 1.2 by 1.2 that was provided, and let's go ahead and do our checks. So if we come here and do all our checks, you can see this is okay, this is okay, this is okay, and area of steel required, area of steel provided, okay, and okay. So we've done for this two part base. This is 1 meter by 1 meter at a depth, at thickness of 350 mm. This is 1.2 by 1.2 at thickness of 350 mm. So let's also take a look at this other column. We'll right click, insert part base, calculate, and our checks, okay, and okay, we have 1.1 by 1.1. So same thing as this, insert part base, we calculate, this is 1 meter by 1 meter. So it all depends on the load that is coming on this very column. So that's what determines the column sizing. That's what Prota-Structure uses to calculate for our adequate column sizes, our adequate part base sizes rather. And now let's look at something different. So let's assuming we designed for this part base, and the part base was as big as this. Then when we also designed for this, we got something as big as this as well. So that means these two part bases will be interfering, or will collide. They will tend to go into each other. So to so when we have cases like that, what we can do is we can choose to combine two of these column base and make both of them have the same part base, just like this. So what we'll do in that case is we'll select this, we'll select both of them, then we'll right click and we'll click on combine selected columns or wall. So we'll click on this place and we'll click yes. So if we select this, you will see both of them are now considered as a combined footing. So what we'll do is a combined column rather. So what we'll do is after we've combined both of them, we'll right click and come to insert part base. Then still sticking with the previous parameters, we'll click calculate, and you can see it is providing this section for us 3555 by 1 meter, but we don't want this type of footing. We don't want a rectangular footing, so I want to keep it square footing. So what I will do is I will click on this square footing, and this is what I have. So this does not really look good for me, so I can choose to increase this size. Let me take out the square footing first of all. So I can choose to increase it, and this looks better. So I can go with 29. I can just type 29 here, let's see, and stick with 1 2. So this is okay. We have to do our checks. This is okay, this is okay, and this is okay as well. All these ones are okay. So y16 at 250. Okay, so we'll click on okay, and now it has provided our part base for our combined column. So what we can do is we'll come to our 3D, and you can see this is our combined footing. So inserting your part base for or designing for a part foundation on put is very straightforward and simple. So remember, click, right click, insert part base, adequate parameters, calculate, do your checks. This has been calculated with accordance to the axial load on this column, and we'll click OK, and that is it. So you can go ahead and design for all of this. So this is the tool left. So right click, insert part base, calculate. 1 2 by 1 2 has been provided. We do our checks. These are okay. Okay, and close this. Right click, insert part base, calculate, look at the checks. This is okay. Then we'll go ahead with this. So yeah, so now we are done with inserting all our part bases, and this is what our part foundation looks like. So it is as simple as this. It is as simple as this. Designing for a part foundation on Prota-Structure, as easy and simple as this. So if this video has been helpful to you, please do well to like it, subscribe to our channel, as we have amazing content coming your way with proper reference to the design code. And do not forget to turn on the notification bell so you get notified anytime we post new videos. Thank you for staying up to this point and have a wonderful time. Thank you.